Cylinder invests 1 at a nominal rate of 36% per year, convertible quarterly. What is the value of Cylinder's investment after 10 years? We can obtain our answer using the function alter n. Recall that a times y is equal to b times m. So by definition, alter n, r per y, n times y, t times y, x at t times y is equal to alter e, j, n, x at t, where j is equal to n to e, a, b, r per y. Remembering n to e is our function that converts a nominal interest rate, in this case r per y, into an effective interest rate per m. N is equal to y to m, a, b, n times y, where y to m converts units in y's into units in m's, and t again is y to m of ab of t times y. Finally, y to m, this is our function that converts n y's into n times b over a m's. So let's make this concrete with our example. The value of Cylinder's investment after 10 years is alter n 0.36 per year, because that's our nominal interest rate, 10 times y, because he's invested for 10 years, and we assume he invested at time 0, because that's what we're told. Yeah? And his investment, of course, is 1. So this is Cylinder's investment. And we've seen that this is equal to alter e, j, and x at t, where remembering that 1 year is equal to 4 times 3 months, because we're told it's convertible quarterly. So j is equal to n to e, 0.36 per year. So that's our nominal rate of interest. So this Windows thing is Windows 8. They're just very silly. This is per year, 0.36 per year, and it's convertible quarterly. So it's 1 to 4, and that will give us n to e of 1 for 0.36 year will be our effective interest rate per quarter. Yeah, and then of course we just need to convert the length of time, 10 times y, from years into quarters, and again the same thing, t, time at which the investment starts, we'll convert that into quarters as well, and both these expressions do that. And of course this y to m of 1 of 4 will convert n years into n times 1 times 3 months, which is n times 4 quarters, because of course there are 4 quarters in a year. So if we have n in years, then in quarters that should be n times 4. Perfectly simple. Alright, now let's do some calculations. Let's calculate j. J, we've seen, is equal to this expression, and we've seen that this expression is equal to r times a over b per m. So in this case, r is 0.36, y is years, and a is 1, and b is 4. So this is equal to 0.36 times 1 over 4 per 3 months, which is equal to 0.09 per 3 months. So our effective interest rate is 9% per quarter. Great stuff. Now let's go to n. N is equal to y to m 1 for 10 years. Again, by version. So that's equal to 10 times 4 times 3 months. And so we have that 10 years is equal to 40 quarters. And finally, I think it should be clearly clear what t should be, but just for the sake of completion and completeness, there's the calculation. If you invest at year 0, that's the same as investing at quarter 0. Of course, I'm sure we'll come across a more interesting example when the start of the investment isn't at time 0, and so we'll have to deal with that there. Okay, so now, just to recap, this is what we started with. We have a nominal interest rate of 0.36 per year, convertible quarterly, for 10 years, and it's 1, and its interest rate starts at year 0. So that is the same as 0.09 per quarter, 9% per quarter, for 40 quarters, and start at quarter 0. And we remember alter E, that's just this expression. And so when we simplify, we now have that at quarter 40 we will have 1 times 1 plus 0.09 to the power of 40 minus 0, which is roughly 31.41. And just for completeness, we'll convert 40 quarters back to years. Of course, that's 10 years. Yeah. So after 10 years, cylinder will have 31.41.